right? What we have covered so far, we have covered three kinds of classification models, right? Can you name them? We have covered regression in detail, linear regression, as well as we talked about polynomial regression. We talked about various evaluation metrics related to regression. And later on, we talked about three classification models. Now you have given the exam also. There were questions from all the three models, I think, in the examinations. Can you just name those three models, algorithmic techniques that we have covered? Yes, anyone quickly who would do? What do you remember? What we have covered? You have seen questions related to some classifier. What was the name of that classifier?
Naive Bayes, sir.
Naive Bayes, correct. That's one thing that we have covered, right? Naive Bayes classifier. That's one of the classification models. What other models we have covered?
Gradient descent. Is that a model?
Gradient descent is an approach to find out maxima or minima, largely minima, right? That's an approach to kind of implement linear regression, right? So we did one, as you said, right? Naive Bayes. Another classification technique that we did was logistic regression. Third thing was, if you remember, support vector machines, right? So under naive Bayes classifier, we talked about conditional probability, if you remember. We talked about Bayes theorem. What is the probability of event A given that B has already happened? We utilize this theorem to make predictions given a data set. And there was one question in the examination. Unfortunately, I think whatever I have sheets evaluated, none of you have performed it correctly, right? The idea is you're given a data set, right? Uh, with some attributes values like A1, A2, A3, and there is a prediction variable, right? I'm calling it as Y1. So based on these input features, the idea is to predict this output feature, predict the class basically. And typically we talked about binary classifiers, right? So what we do is, given that these are the values, right? What is the probability of this y variable being yes or no, right? So we calculate probability of y being yes, right? Probability of y being no. Whichever is higher probability, we say that that is the class, that is the predicted class, right? So from this data, what typically we do is we check conditional probabilities. So there is no training sort of thing largely required. We typically see the unseen variable. What are the values of A1, A2, A3? Given that A1, A2, A3 has already happened, what is the probability that Y belongs to yes or no, right? So we need to calculate the probability of yes, probability of no. Which one is higher? That is what we call it as a prediction. That this will be the class. That was largely naive Bayes classifier. In detail, if you want to see, you can again go through the examples which we have covered in the class, as well as solve the example which was there in the examination. Any doubts later on, you can always write to me. I can take it up. Second part is the logistic regression, right? Uh, Typically, regression, what we have seen is it's largely, we said we want to predict continuous, right? In regression only. I'm not talking about logistic regression, linear regression, right? or polynomial regression. We predict continuous variables like house price, stock price, and so on. But when it comes to logistic regression, we use a particular function known as sigmoid function, which brings the values of those things, right, those particular variable in a range from 0 to kind of 1. 0 to 1. So kind of a transformation it is doing and values it is bringing in terms of 0 to 1. And then we also have some threshold with us, right? When we predict using logistic regression, right? Whatever the value we are getting, we compare it against the threshold value and accordingly take a call whether this belongs to yes class or no class, right? The probability is higher than the threshold. Okay, we say, okay, this belongs to this particular class, yes, right? And otherwise, if the probability is low or the value which we are getting from logistic regression is lower than the threshold, we say it belongs to no class. So that was logistic regression, a classification model again. Then came SVM, support vector machines, where we looked at diagrams like this, if you remember, right? So under SVM, we talked about two things. One is linear SVM, another is non-linear SVM. So if I talked about linear SVM, the data sets which we get, right? So typically we get this kind of data sets. We see a clear boundary between them, right? And we call this as a boundary. Basis this, we can divide our data into two sets, one belonging to this yes class, another belonging to no class. And we try to come up with a hyperplane, if you remember, right? We said we will come up with an hyperplane like this. And there could be multiple lines or multiple hyperplanes that I can draw to segregate these boundaries, right? But I'll choose the one which will maximize my margin. I have given one question also in SVM, right? What kind of boundary? Will it choose any arbitrary boundary, right? So there can be multiple boundaries that I can come up with, but which one it will choose, which will maximize the margin? That is what we have studied, right? Mathematics behind this. We said that, okay, since this is applied machine learning course and you were not very comfortable, we haven't covered that. So that was the concept behind it. Now, this kind of data is linearly separable. Linearly separable means I can simply draw a line or a hyperplane depending on the dimensions I am working, and then I can separate my two classes, right? But in real life, the data has a non-linear nature. Non-linear nature means maybe I have a crosses like this, and let's say there are circles like this. So I cannot draw a straight line in some way and cut it out, right? And cut the boundary. But the boundary becomes little more complex rather than a linear. If I draw a circle around it, right? Outside the circle, there is a cross, and inside the circle, there is uh, uh, a 0 or a O, you can say, right? Basically, I'm drawing a boundary which is non-linear in nature, but separating the two classes. Now, this non-linear nature of data you will actually see in real life, right? But there's nothing called like that we are coming up with some non-linear boundary using SVM. Though the name is non-linear SVM, but we are not doing it like this. Rather, actually, we try to transform this data onto different scale. We try to transform the data so that I can fit a linear boundary separating the two classes. This transformation things you might have covered in your geometry, right? Maybe in some smaller examples. I'm not saying very complex examples that we cover in SVM, right? But smaller examples we you must have seen when you transform using coordinates here and there, and then you are able to project the data in some way that you are able to fit a linear boundary. So using some transformations, we make a non-linear data to a linear kind of, where you, not a linear, I would say, where you can fit a linear boundary to separate the two classes, right? And then our job is done, right? The classification is done. I am able to fit a boundary. But what I need to do before I find out a hyperplane or a linear line is I need to find out the exact margin, right? Or I need to do some form of transformations, right? So when we do transformations, right, there's another name I would give. The transformation is done using some functions, right? These are known as kernels. In SVM, you will hear one term, kernel. What is kernel? You are converting some nonlinear data using a kernel to a linear data, right? Now, these kernels, right, they're not so easy. These kernel functions will vary from data to data. It's not only simply one kernel function that I have and I can transform every kind of data to a linear, I can transform every kind of data so that I can fit a linear boundary. There's not single kernel, right? I have to understand, right, my data clearly and then apply the kernel. And I think this is always a tough problem, and many of the organizations are working on different kinds of kernels, right, to come up with, if this is the kind of data, maybe this kind of kernel will fit there, right? So that's the idea. I hope this gives you some brush up on what we covered before mid semester. Any questions so far?
No, sir.
Are we clear with the things? Some idea you've got?
Yes, sir.
Is it fine with everybody? Ali? Can you hear me, Ali? Ali, Akash, Abhinandan, Divija, Shweta. Okay, Ali has left. Shweta, is it fine? May I get some response, please? I'm only getting a response from one candidate. Okay, you can always unmute and speak as well.
Yes, sir, clear.
Okay. No doubt. Should we move ahead to another kind of classification models, that is decision tree? Should we move ahead? This is bit easy in interpretation and with easier mathematics. So I'm going to cover some mathematics today, but that is easier.
Okay, sir.
I hope all of you have pen and paper handy with you. How many of you have pen and paper handy with you? This is very simple question. The answer is yes or no. May I expect a response from everybody?
Yes, sir.
You have. Okay. Again, one candidate responding.
Yes, sir.
Okay. Two people have responded. What about the rest? Okay, let me move ahead then. It's up to you, right? Decision tree. Now, what is decision tree, right? We have seen various kinds of data sets, largely a CSV file. Some input features are given and we are supposed to predict the output class. What we are given is the historical data, right? Using which the model learns some form of equations or certain boundary basis which it decides the classification, or in naive-Bayes classifier, we use the conditional probability to decide which particular class this particular data may belong to, or particular record may belong to. Now, what we are trying to do here is we are trying to create a decision tree, as the name indicates, right? I will come up with a tree which will test one attribute at a time, right? Starting from the root, depending on how many values it can take from data set, it can be very clear, right? And then come up with those many branches, right? Let's say if you have fever or not, that's one attribute, yes or no, right? So I'll have only two branches out of that attribute. When I will test whether fever, yes or no, so I'll have only two branches coming out of it. So at every node, I'm going to test an attribute and then create those many branches according to the number of values that attribute can take, unique values can take. And I will keep on testing an attribute at each level until all the attributes are tested, right? Or I am able to classify my records perfectly, even at some intermediate test, then I can also stop. One is I am done with all the attribute testing. Second is I'm able to classify the records at some intermediate level, then I'm also going to stop there. Let us understand this, whatever I've said, right? So what decision tree is? Look at this, how to understand a decision tree. Now, I may have one variable within my data set, what this decision tree is showing, right? Outlook. What is outlook? Outlook of the day, right? Day could be sunny, it could be overcast, it could be rainy. If it is sunny, right? If the day outlook is sunny, maybe I'm not getting a perfect classification here for all those data sets, right? And if the outcome is overcast, I am getting some value, I mean, all kind of records which belongs to yes class. If outlook is rainy, again, I'm not getting all the records belonging to one class, then I'm again testing it, right, further. So basically what I mean to say is, again, I'll show you with the help of a data set, but at each node, what I'm going to test as of now, what you can understand is outlook, sunny, overcast, rain, and sunny. Now, when I'm not able to classify all my records which have a value sunny to a particular class, then I have to test another one. That is humidity. Humidity high or normal, right? Then within overcast, right? The answer is yes for all the records. So I'm stopping here. But to this branch where the outlook is rainy, then I'm going to check wind. Wind strong or weak, basis that I'm going to take a call. So what I'm trying to understand is I have some set of input features. I want to predict y, and this function, the set of input features to y, right, which is my output, that is what I'm going to learn. And y is discrete valued. That's why we are calling it as a classification problem. If it is a continuous one, it will be a regression problem, right? So we are calling it as a classification because it is a discrete value. Now you see there are a set of functions that you can learn, and each of them we're calling it as an hypothesis, right? Function hypothesis, and each hypothesis H is a decision tree. Now let us understand this, how this decision tree works, and then these things will be more clear. Now look at this. This is the data set given to me, right? What my intention is, whether I'll go to play tennis or not, it depends on these four input features. Four input features. One is sunny outlook, another is temperature, third is humidity, fourth is wind, and then this is my target class. Play tennis, whether I'll go to play, whether I went for playing tennis or not, right? I would call it this because this is historical data, right? Using which I am going to create a decision tree, and basis that I'm going to take a call for the unseen records, right? So this kind of data set is given to you. How many records are there within the data set? In this snapshot, how many records you can see?
14, sir.
14 records. How many input features? How many input features? Okay, total how many features are there? How many
Total
features are
6.
total? 6 features are there. Okay. This is not going to play a major role, so let's ignore this part, right? Sorry, right? Total 6 features we have seen. Now, what are the important input features left?
Sir, 4.
4. Which are those?
Outlook, temperature, humidity, and wind.
Wait. And what is the output? Play tennis, yes or no? Right? Is this point clear? How to interpret the data set?
Yes,
Is
sir.
this fine? Is this fine? Yeah. Now, this is what you have seen in the last chart also, right? What I'll do is I'll come up with this kind of a decision tree. When you look at Outlook, right? How many values you can see in the data set? It's sunny, it's overcast and rain. Can you see any other value within the data set?
No, sir. 3 values only.
3 values. So I'll create 3 branches. When I'm testing Outlook, I'll create 3 branches: sunny, overcast, rain. Now let us look at when I'm taking sunny, right? These 2 are the features, these 2 and these 2. How many records total for sunny? How many records for sunny? Sunny value.
5, sir.
5 records. I am writing it here. Now total there are 5 records. Out of those 5, look at the play tennis value. How many yes and how many no? For those 5 records, look at the play tennis value. How many belongs to yes class and how many belongs to no class?
Sir, 3 no, 2 yes.
Absolutely fine. So these are the observations that you need to make, right? It's good that you are making those observations. It will be easy for you to kind of do some calculations later. So if I take this branch, right, and I land it up here, I know I have 2 records belonging to yes, 3 records belonging to no. So I don't have a proper kind of division here, right? When I say what proper division, let us look at overcast. How many records belong to overcast? 1, 2, 3, and 4. Can you see that overcast has 4 records?
Yes, sir.
Now let's do the same thing for overcast. How many records belong to yes and how many records belong to no? When the value is overcast, how many records belong to yes and how many records belong to no? Just look at the play tennis value.
Sir, all are yes.
All are yes. All of you agree? I'm stopping here just to take concurrence from other candidates. Are you able to follow what we are doing?
Yes, sir.
Okay. Now, when you go with the overcast, right? Overcast, yeah. All records belong to yes class. Now this becomes my leaf node. Here. Do I need any further classification along this branch? Or do I need, not classification rather, do I need to test any other attribute? I know if that outlook is overcast, I'm going to play time. That's what my historical data says. I need not to check any other attribute because for all 100% records where the value of outlook was overcast, I went to play. Make sense? Why I am testing another attribute here and why I'm not testing any other attribute here? I'm stopping. You see, after overcast is yes, this particular branch I'm stopping. Is it making sense why I'm stopping?
Yes, sir.
Now let's look at the third one, rain. How many records belong to rain? 5 are left only, right? 5, 4, 9. Total we have 14. So you can quickly give me an answer. If it is raining, how many records belong to yes and how many records belong to no?
Sir, 3 yes and 2 no.
3 yes and 2. So is it giving me any kind of a pure classification here? Under, if I go for outlook as rain, still there is, we call it as an impurity, right? Because some records belong to yes, some records belong to no. We call it as an impurity. So if I take sunny and rain, I still need to test more attributes, right? So within overcast, all records belong to yes class. So I call this kind of partition as pure partition, where all records belong to one class. That is a pure partition. So if outlook is overcast, whatever the records belong to that, they all belong to one class. So this branch is giving me a pure partition. While if I am here and if I am here at this range intermediate nodes, I have impure partitions 2, 3, 3, 2. Right now, for humidity, after outlook, I am testing humidity. So this is sunny, right? For those 5 records. After test, I am testing humidity. If it is high, 1, 2, 3, 4, high or normal, right? So under these, where the outlook is sunny, I have this as high, and here I have high and normal, right? And one record normal. So if you look at this, out of 5 records, for 3 records, humidity is high and plate anise is low. And that is kind of giving me 0, 3 kind of thing, right? 0 records belong to yes and 3 records belong to no. When it is normal, right, it is giving you 2, 0 kind of thing, right? So here it is kind of 4, 0, right? So look at this. I am getting pure partitions here. So this becomes my leaf node. This becomes my leaf node. Does it make sense? Now, once I've reached a pure partitions, at this stage, I have reached pure partition, right? At this stage, I have reached pure partition. So I need not to test any other attribute. I'm not going to test temperature or wind further here specifically. When you look at this rain, right? We said yes 3, no 2. Now I'm going to check wind. Wind is weak or strong. If wind is strong, let me check first the rain portions, right? There are 3 records here, 1 here, 1 here, total 5. So if I look at the wind, this for these 2 weak, this one strong, weak and strong. When you see this combination, right? Rain with strong wind, it's no. Rain with strong wind, it's no. But rain with weak wind, it's yes, right? So I'm getting pure partitions. I'm getting pure partitions. So strong, uh, rain strong, rain, no, this is sunny, right? This is rain weak, this is rain strong, no. So I'm getting 0, 2 here, 3, 0 here, right? So 3 yes, 0 no, right? 0 yes, 2 no. So I'm getting my leaf nodes. So are you able to follow first that how this tree is making decisions. How to create this tree is a separate question, but how this tree is making decisions, is it clear?
Yes, sir, clear.
Is it fine with everybody? May I have some response? If you have any questions, please raise right now. Shweta, Ali,
No question, sir.
are we good so far?
Yeah.
Now the obvious questions that you might have. Why should I test outlook first? Why not temperature? Why not humidity? Why not wind? I could also test first humidity. I could also test Ali, you must have typed some message. I have received it right now. 9:54 it is showing after 10 minutes. Okay, anyway, I think you were typing 5 yes and 4 no's, right? Okay. So you must have a question in mind, right? Why should I test outlook at the root? Why not temperature? Why not humidity? Why not wind? Yes or no? I could test any attribute. Why should I go for outlook first?
Will the results change, sir, if we evaluate some other variable at the root?
Results may not, predictions may still be correct, but the depth of the tree may grow, or it may be lesser also, depending on like whether we are moving towards pure partition or not. The idea is to move towards pure partition as early in the tree as possible. That idea is clear. What is pure partition? At a branch where I have all the records belonging to one class. If you look at overcast, I am able to reach within one attribute test, right? But if you look at humidity and wind, I mean, sunny and rain, I need to test one more attribute and then I am able to reach the pure partitions. So the idea is to reduce the depth of the tree, or if you relate it to height, right? You can say it's idea is to reduce the height of the tree. Lesser the height, I'll be able to make that decision early in the tree, right? So this 14 record you see, this is the kind of tree. But when you have 10,000 records, or you have 1 million records, or you have 10 lakh records, this tree depth matters a lot. You remember your data structures course? Complexity is proportional to log of n to the base 2, right? If you remember binary search tree. So at every node, you are testing something if you're going to search within a binary search tree. Height is also proportional to that. So somehow those computational fundamentals are also coming into picture. However, the idea is to reduce the depth of the tree. That should be kept in mind. And do you agree to that, or tree of any depth will have the same amount of computations? Yes.
The smaller the trees are, the faster it will be.
Faster it will be, right? Because I will be restricting myself to a lesser number of condition checks, right? Or attribute tests. So concept is fine, right? We need to stick to the tree with the lesser height, right? Idea is to move towards pure partition, in other words, I can say. Now, this particular chart is only asking about how to choose the best attribute, right? Decision tree represent a disjunction of conjunctions on the constraints on the values of attribute. This is one way they have kind of tried to express it. And if you look at this, right, why the name expressivity, right? It's very easy to interpret how the decision has been made, right? Once you have a decision tree, you know, okay, these were the values I got, and along this particular path of the tree, I followed to make a decision. There is an explainability also, right? Because the outlook is sunny, humidity is normal, so yes, I'll play tennis. So there is another fundament, I mean, another, I can say, what should I call it? A kind of a topic I can say within AI is or ML is explainable AI. Why this particular decision? The models are making decisions, but when they are asked, okay, why this? Can you explain it? How this we have reached it? Because this gives us maybe the decision may be incorrect, right? But this gives us an idea how the model is actually reaching to that particular decision. So if we are able to trace that, we can kind of find out the anomalies within the model or the drawbacks of the model and then maybe retrain it and so on. But when it comes to decision tree, they have a self-explainability thing, right? When it comes to linear regression and all, it's not very explainable thing. You are getting an output, right? Some weights were there and all, you got that output, but it's not very explainable thing, right? But when we come to this decision tree specifically, it's very easy to interpret, and maybe we are used to kind of flow charts in our earlier days also, and we are able to relate it better, and we are calling it them as a decision trees because we are checking attribute test at every node. Now, when it comes to uh, choosing the best attribute, right, which I talked about, how do you decide which particular attribute should I go with, right? There are some possibilities this chart indicates. I can randomly select any attribute, right? I can choose those attributes which have least values. Least values means least type of unique values. If I talk about wind, it was strong and weak, only two values possible, right? While if I look at uh, the attribute which we were testing, right? Or outlook, it was having three values. So should I go with the least values? Should I go with the most values? So these are some of the options which are given. Choose the attribute with the smallest number of possible values or choose the attribute with the largest number of possible values. But these may not be true all the time. What is an important thing that we should keep in mind is the max gain aspect, right? This is what will help us. Now, whatever we said, right, I want to go towards pure partitions. How I can mathematically prove that, okay, this particular attribute will take me towards more pure partitions than any other attribute in the data set. So that is given by max gain approach. Choose the attribute that has the largest expected information gain. Now, what is information gain? We will talk about it, don't worry, right? The attribute that results in smallest expected size of subtrees rooted at its children. That's what we talked about, right? We want small subtrees, right? Smaller trees, because smaller trees, lesser computation, and will reach fastly towards pure partition. There is one algorithm that is ID3. ID3 algorithm which uses max gain method of selecting the best attribute. So when you implement it in Python, it's just a library call. All right, it's just a library call. But how to measure this, right? I'll come to this portion little later. What this mathematical things, the first four things, 4 points which are mentioned, right? But this point, this formula you should remember. This formula you should remember. Then it will be easy, right? What this formula is, we will talk about it soon. It's a measure of entropy, information, and all what is mentioned on the chart. How to measure it? That is what we are going to do right now. What is entropy in general, right? It measures the amount of information in a random variable. Random variable which can take any sort of values, right? Or mathematically, if in statistics you say it random variable, it's kind of a function that say that transforms maps any given set of integers on one to the natural numbers. Something like that they will call it as a formal definition. But let's not be too formal. Let us try to understand the concept. They have just explained now this formula, right? Which they have written it here. I'll come to this later. That will be better. Let me take a data set and then okay. Now let us try to understand from these visuals what do we mean by information gain and what is more informative. What is why we are talking about information gain and what kind of information we are talking about. Which test is more informative out of these two? What is written is split over whether the balance exceeds 50K, right? Split over whether the applicant is employed, right? So these were the points, right? These are the same set of points. I'm drawing this one boundary based on this particular attribute split. And I'm drawing one boundary based on whether the applicant is employed or not. So you exceed is this way, the balance exceeds 50K. This is one attribute, right? It has values yes, no kind of values in the data set. This is another attribute, employed. It also has values yes and no. And there are these many records, right? Whatever the points you can see. One resulted in this kind of a boundary, and you can see the class distribution. And one resulted in this kind of a boundary. You can see the class distribution. Which one do you see is more informative or more better, I would say, whatever the concept we have covered right now, right? Moving towards pure partitions. Which one do you see here is more better for an attribute test at an upper level in the tree? Whether should I go with balance exceed or should I go with employed or not?
Unemployed or not.
Employed or not? All of you agree to this? What Anish has mentioned? Okay, let me ask Anish, any reason for that? You have quickly given an answer. I could interpret that you have a reason for that also. One line reason?
It better classify the data.
Better classify. Why you are saying? Because on one side of a boundary you have one class, on another side of boundary you have another class. Here you see there's a mix. There's one record coming this side. There are 4 records of the other class coming this side. So still what I would need to do is another test of attribute, right? But this is also kind of impure partition because I got this. This is also kind of impure partition. But if I look at this, this is pure partition, right? I have completely segregated things. So the test 2 is kind of giving me more information rather than the test 1. Because I know that, okay, basis this test, I am able to classify these two better. Is it making sense to all of you what I said right now? Why test 2 is by unemployed, employed is better than this testing whether the balance exceeds 50K or less than 50K? Is it making sense why the split 2 is better? Shweta, Ali? We are going to use it, right, to create a decision tree. I mean, it's very, very important that you should understand this. Like Anish is kind of looking at it, right, visually and able to understand, grasp, immediately given an answer. So calculations will become very easy for him. It's just a mathematical thing. But what is the concept? That will be more clear through these visuals. Yes, please. Ali, any doubts? Shweta, any other candidate who has joined later? Vasu, if you are there, you used to interact, but I'm not sure whether you're there in today's session or not. Yamuna Krishnan, Ali, please go ahead. Yeah. I'm unable to hear you, Ali, if you're speaking. Anish, were you able to hear Ali?
No, no, sir.
Ali, can you repeat, please? Ali, you are on mute. Network issues. Let me rejoin after restarting. Okay. Shweta, is it fine with you? Any other candidate with any questions? Please do ask right now. You can expect a question in the final exam. I'm telling you upfront right now. 8 session before from decision trees. Okay. Now, when you look at this kind of a class, right? If I look at this, right, impurity, right? Well, we talked about impurity and entropy, right? So kind of what entropy does is it measures the level of impurity within one set of records. If I have this boundary, right, and you see it's a mix of both the classes, and if you look at this, right, it is only one class. So this is a kind of a pure class having lesser, almost zero impurity, right? But this is an impure class. When we do a split on an attribute, our objective is to move towards these pure partitions, right? So I should choose an attribute which gives me the less entropy, right? Less randomness. I'm moving towards pure partition, and that will lead to the maximum information gain. That's what I'm trying to convey from these two visuals. All of you agreed that, okay, this split is better compared to this split, right? Because I'm getting something pure partitions. And this is giving me more information gain than this particular split, right? Similarly, if I visualize this, this is more impure kind of data set than this, because all the records here belong to two classes. Here it's only one class. So our objective is to sort of move towards purity. Purity means belonging towards one class of data sets. So another visual, now the impurity can be measured quantitatively also, right? If you look at this, there are a good number of records belonging to this green dots and plus signs, right? So this is more impure class compared to this, right? Where you have only two records belonging to a plus and most of the records belonging to these green circles. This is minimum impurity, right? Which all the records belong to this. So our objective is this one, right? Objective is this one. But practically many times if we are not able to achieve this one, at least towards the lesser impurity. And that happens when our data sets are very, very large. The data sets which I will deal with right now, conveying the concept to you using examples, that data sets may not be that large, right? So we will be able to achieve this minimum impurity levels that we are going to cover, right? But practically when you have 1 lakh, 10 lakh records, may be possible that you have impure classes and you may have to stop there also, right? Why? Because all those concepts which we have covered earlier, I will bring those and relate it to them. Now, the same thing has come up right again with that formula. If you look at this formula, and if you look at this formula which I said, it's same. And this is the way I measure this impurity within the data set. So you can write it like this way also. pi log of pi to the base 2. What is pi? Probability of a record belonging to a particular class. Probability of a record belonging to a particular class. Now, when I look at my data set, which we have done this, there are two classes, right? There are two classes, play tennis, yes and no. So the number of values in the target feature are the number of classes that I have. The target feature has two classes, yes and no, right? Now, when I look at the data set, there are 14 records. Out of those 14, if I look at how many have yes values and how many have no values, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 has yes values, 5 has no value. So probability of a class belonging to yes is 9 by 14, while probability of a class belonging to no is 5 by 14. That's what we are calculating. Okay? So when I have to calculate the impurity of a data set at a larger level, right, I'll expand this. Now, I is equal to 1 to n is basically the number of classes. So in our case, n is 2 only. Yes or no, considering the data set that we were having. Right? Look at this, two classes, right? If it is two classes, okay. What is the entropy of a group in which all the examples belong to same class? In our data set, I said 14 are there. Out of those, yes 9, no 5, right? What they're saying is if 14 are there, all belongs to yes, 0 records belong to no. So now how to expand the entropy thing is pi log of pi. Now probability of a class belonging to yes is 1. So 1 log of 1. Probability of a class belonging to no is 0, right? So 0 log of 0. So log of 1, if you know, this term is 0, this is 0. So both the terms is 0. So 0 plus 0 is 0. So there is no impurity in the data set. Entropy is a 0. So our objective is to achieve 0 entropy. But when you look at a data set, let's say 14 records are there. Out of those, 7 yes, 7 no. So probability of a class belonging to yes is 1 by 2 and log of 1 by 2. There's a minus sign here, right? Minus 1 by 2 log of 1 by 2, because 7 by 14 will be 1 by 2, right? I'm directly writing that. So can somebody quickly calculate what is log 1 by 2 to the base 2? What is log 0.5? Yes. What is log 0.5? Quickly check it using calculators. You have to use
Minus
base
1.
2, minus 1, right? So minus 1 by 2 into minus 1, minus 1 by 2 into minus 1. So this becomes 1 by 2 plus 1 by 2, 1. So this is the highest entropy. When 50% of the records belong to one class and 50% of the records belong to other class, that is the highest entropy, highest impurity that we can have. If it's a 60-40 split, it will bit reduce. If it 70-30, further reduce, 80-20, further reduce. Is the concept of entropy and how it relates to impurity, is it fine? Is this clear to everybody?
Sir, can entropy come in negative value?
Can entropy come a negative value? Okay. What do you think? What do you think?
Hmm. Just for coming it to be negative, the summation value should be positive. And for that, the value of inside the log should be greater than 1, but the probability cannot be greater than 1. So, yeah, it cannot be
Exactly.
negative.
Very good. Very good. Right. So one thing is, I clearly, there are two ways, right? One, you said the probability cannot be greater than 1. So log values will always come to be negative. And we have already have a minus sign around this. So the value will always remain positive, and at max it will can go to 0. So what is the maximum when we have maximum entropy? When we have 50% record belonging to yes, 50% record belonging to no. And we already checked if 14 is the now total number of records, 7 yes, 7 no, I am coming up with a entropy value of 1. And when it comes to pure partition, all records belong to yes, the minimum value it can attain is 0. It cannot go because maximum value of probability is 1. It cannot be 1 point something, right? So minimum value it can attain is 0. Maximum value it can attain is 1. So entropy will remain between 0 and 1. Does that make sense, Anish?
Yes, sir.
Now, basis this, right? Whatever we have studied, we will apply this to find out which attribute is the best and the most useful, right? To be test at the root level, and what should be what kind of tests, I mean, what should be at the next level and so on. How should I decide it? That's what we are going to learn quickly, right? Entropy measure, what it measures, impurity of a collection of examples, right? S is a collection of training example, P positive with one class, P negative one class, right? So this is what we got it, right? So we have already covered this. So 9-5 split when we are getting, right? So minus 9 by 14 log of 9 by 14 minus 5 by 14 log of. So entropy is 0.94. 0.94 is quite high again because the value is close to 1. The value being close to 1 means higher impurity, right? 7 and 7, highest impurity, right? We already calculated this. So your answer, right? This number uh, and where the entropy value will lie. It is also documented here. Now, how do I calculate the information gain value that we were talking about? So what we are talking here is entropy of parent. When I say entropy of parent, at the highest level, first, without considering any attribute, what is the entropy of the data set? Like if I talk about our data set, 9-5 split. So we calculated here, right? If I take this example, this is the entropy of the data set, right? At a parent level. Then at a child level, what is the entropy? If I consider this attribute, this is the entropy. If I consider this attribute, this is the entropy. If I consider this attribute, this is the entropy. How to calculate that? I'm going to come back to that. But basically, if I talk about that Outlook example, right? Sorry, yeah, Outlook. If I consider Outlook, all right, what entropy levels I am achieving? At the highest level, I have 0.94, right? That is what we can say from 9-5 split. If I consider Outlook, what is the entropy level I am achieving? If I consider, let's say, wind, what is the entropy level? If I consider, what was the other attribute? Temperature, right? Temperature, wind, and one more, right? Humidity, right? I'll check each one and calculate the entropy levels, what we are getting. So I'll check for Outlook, humidity, temperature, and wind. I'll try all four. I'll calculate the entropy levels. Now I know at the base I have this much entropy, but when I am taking one attribute, right, at a time, what is the entropy level? So I might have with humidity, let's say 0.6. I'm just taking some hypothetical value. Sorry, with outlook 0.6, with humidity, let's say it is 0.7, and with a temperature, it is, let's say, 0.75, and with the wind, it is 0.8. What I'll do a subtraction. 0.94 minus 0.6. This is 0.34, right? 0.94 minus 0.7, 0.24. 0.94 minus 0.75. This is 0.19. 0.74 minus 0.8, 0.14. So this value is giving me information gain. Whichever attribute will give me the highest information gain. Because if I consider, you see what it is trying to say. At the base highest level, the entropy is too much, 0.94. But if I take outlook, it is reaching to 0.6. If I take humidity, 0.7. If I take temperature, 0.75. If I take wind, 0.8. So which particular attribute is reducing the entropy a lot is the first one. So I'm just subtracting it with, and subtraction will give me the information gain. Whichever attribute will have the highest information gain, that is the attribute I'm going to choose for a split. Does that make sense? Detailed calculations I will show, but at a conceptual level, what we are trying to do is, does that make sense?
Yes, sir.
People are dropping. Okay. You look at this, some example is being taken, right? Entropy of the parent minus average entropy of the children, right? What is average things? We will cover that, right? Don't worry about that. So you can see this example entire, there are 30 instances total, right? So maybe out of those 30, right? For one attribute, we have got 17 instances. So accordingly, we have calculated the entropy. It is 0.787 here, right? If I look at another, there are 13 instances, right? So 0.391, parent entropy 0.996, right? Now, what is average entropy, right? If you look at, if I take one value, how many records are there here? 17. If I take the other value, there are 13, right? So 17 by 30 into what the value this is generating plus 13 by 30, what is the value this is generating? Weighted average kind of a thing we are doing. And overall information gain we are calculating for this particular attribute, right? And then we are calculating the information gain. This is for one attribute, right? How to calculate information gain. I will take an example of data set and then showcase also. Okay. So this is all theory, right? Information gain is the expected reduction in the entropy. That's what we have covered, right? Caused by partitioning the examples on an attribute. The higher information gain is more effective, the attribute in classifying the training data. That's all, right? So gain assay is entropy of the total data set minus summation of entropy of the values of those, right? And that is how you calculate the gain, information gain with respect to this attribute A, right? So decision trees can be used for regression or classification, but we are going to talk more about a classifier, and that is what the popular uses of decision tree is. So all these are some, there are some decision nodes, there are leaf nodes, right? Decision nodes, you have to test the attribute. Leaf nodes will give you the classification of that particular path, right? That's what we have covered also. You look at another kind of example, whether to approve the loan or not. First, we are checking whether the person is employed or not. If yes, what is the income? Income, if it is high, approve. Income, if it is low, reject. If it is not employed, check the credit score. If credit score is high, yes, approve, otherwise reject. So just a simple example to illustrate that, right? Look at this particular data set which we earlier used. Create a decision tree to predict whether a tennis will be played on the particular day or not, right? Same data set, we know how many yes records are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes 9, no 5, right? So very first step is uh, so this is a step-by-step thing that is mentioned, but very first step, calculate the entropy of the data set, right? So this is all theory, how the algorithm works. That's what I'm going to talk about. This you can read it and it will be very easy for you to understand. Step-by-step things are given, right? This is the entropy level, right? You can see now this is graphical representation, Anish, which the question you asked whether it can be negative or not. So it can be 0, can go up to 1 and then come back again to 0, right? So this is entropy. It cannot go negative. Right? Okay, coming to the data set again. Yes, 9, 5, no. Let us start now calculating the step 1. At step 1, this is what the value we are calculating, 0.94. How I have calculated? 9 by 14, log of 9 by 14, 5 by 14, log of 5 by 14. And these are the values you will get. This is the entropy of the data set, the impurity within the data set. If all belong to yes, right, which is very impractical, right? But let's create a hypothetical situation. So what will happen? 14 by 14, log of 14 by 14, then 0 by 14, log of 0 by 14. What will happen? This will become log 1, this term will become 0, this term will become 0. Every day I can play tennis, regardless of outlook, temperature, humidity, windy. This is what practical meaning is. But actually, this is not the case. We have 9 yes, 5 no's. So there is some randomness in the data, impurity in the data. Now, which one should I pick first? Outlook, temperature, humidity, and windy. We know we need to pick one attribute, check the information gain, right? How to check it now? Let's look at that. Let's talk about first outlook. Outlook has 3 values: sunny, rainy, and overcast. Right? Now, how to check it? When it comes to sunny, right? All these calculations I asked you earlier, right? Sunny has 5 records. 3 belongs to no, 2 belongs to yes. Outlook has, rainy has 5 records. 3 yes and 2 no. Outlook has 4 records, all belonging to yes. Right? Now, how to calculate entropy when the outlook is sunny? Total 5 records. So 2 belongs to yes, 3 belongs to no. So 2 by 5 log of 2 by 5 for yes, 3 by 5 log of 3 by 5 for no. And this value will come out to be 0.971. Are you with me so far?
Yes, sir.
Now, when it is overcast, let's talk about this. All belongs to yes, right? So probability belonging to yes class is 1, probability belonging to no is 0. So 1 log of 1, 0 log of 0, so this becomes 0. So no randomness here. But when it comes to play tennis, right, it is now the other way around. 3 by 5 log of 3 by 5, 2 by 5 log of. But if you see, the terms are similar. So the results you are getting are similar. Right? Because here 3 yes, 2 no's, here 2 yes, 3 no's. So final thing is the impurity within the data set is same. Out of 5, 2 belongs to one class, 3 belongs to another class. So it is indicating impurity. Why these two values are same? Understood? Yes or no? Anish?
Yes, sir. Yes, sir.
Now, weighted average. Weighted average means how many records belong to this? Out of 14, 5. 5 by 14 into 0.971. There's no requirement of weighted average for this because it will boil out to 0 only. So if you want, I can write 4 by 14 into 0 plus 5 by 14 into 0.97. So this will be the weighted average entropy, which you must have understood from this diagram, right? 17 by 30, 13 by 30. Right? Now, if you look at it, this should be the next step, right? Look at this. We got this value as 0.693. When I take outlook, weighted information, weighted impurity is 0.693. What is the information gain? 0.940 and 0.693. Take a subtraction. I got 0.247. .247. Does that make sense?
Yes, sir.
Okay. Now let's take another one, another example, temperature. Right? Temperature, now it could be hot, mild, and cool. For hot, right? There are 4 records, 2 no, 2 yes. For mild, we have got 6 records, 4 yes, 2 no's. For cool, 3 yes, 1 no. Right? Now, if I ask you, what should be the entropy if I talk about the value as hot? What is the entropy? Without calculating, you can tell.
1.
1. 50% records belong to one class, 50%. Highest entropy. What is the highest entropy value? 1. So even you can calculate 2 by 4 log of 2 by 4 minus 2 by 4 log of 2 by 4. We have already done it, right? Minus 1 by 2 log of 1 by 2. Log of 1 by 2 is 1. Log of 1 by 2 is 1. So 1 by 2 plus 1 by 2, it is 1. So this value is 1.0. Now 4 to split, right? So 4 by 6 out of 6, right? 4 records belong to yes. 4 by 6, then 2 by 6. So this value is 0.918. Again, entropy is high for this also. Cool, 3.1. 3.1 is 3 by 4 log of 3 by 4, 1 by 4 log of 1 by 4. What is the next step? What is the next step? Yes. What is the next step, please? What we did here to reach out to value of 0.693? Quick answer, please.
Probability into entropy.
Come again, please.
In the next step, sir, we'll multiply probability by entropy and summing.
Weighted average
summation.
kind of weighted
Yes, sir.
average, right? Okay. How should I calculate the weighted average now? Please tell me. What should I write? How many records
Second,
here?
sir.
How many records here? In
4,
the
sir.
first one, 4. Divided by
14.
14. Multiplied with
Sir, 1.
1. Next,
6
6.
divided by 14.
Hmm.
Multiply by 0.918.
Good. Last one.
Plus 4 by 14. Multiply
Hmm.
by 0.811.
Right. So this is the way to move forward, right? And when you calculate it, right, this is what it is. And you are getting this as 0.911. So at source, the entropy was 0.940. So this is the information gain that you have got. This is the information gain that you have got if you take temperature, right? Now let's talk about the third, humidity. Humidity has two values, right? Normal and high. How many records here? 7 in normal, 7 in high. If I talk about yes, 6, no, 1, right? If I talk about this, yes, 3, no, 4. Without calculations, which part should have more entropy? Any guesses?
The high one.
High one, right? Because it's a 3-4 split, it's a 6-1. Only one record we are. So if I calculate it right now, so this will be 6 by 7 log of 6 by 7, right? Minus sign will be there, minus 1 by 7 log of 1 by 7, right? For this, it will be log of, yeah, 3 by 7 log of 3 by 7, 4 by 7 log of 4 by 7. And these are the values you can see. Next step is weighted. Weighted averages 7 by 14 into 0.985 plus 7 by 14 into 1. So basically half of them. Okay. So if I do this way, I got 0.789. Source 0.940 minus 0.789. So 0.151 is the information gain if I take this humidity as. We have calculated for outlook, temperature, humidity. What is left is wind. Again a 7-7 split, but within 7 I have, no, let me check, 1, 2, 3, 4, 5, 6, 7, 8, sorry, 8-6 split, right? So if you look at this, if it is weak, right, I have 6 yes, 2 no, 3 yes and 3 no. Without calculation, can you tell me the entropy of this when the wind is strong?
1.
1, because 50-50 split, right? Maximum entropy, and that's what we are getting. And if I calculate it the same way, 6 by 8 log of 6 by 8, 2 by 8 log of 2 by 8, and I'm getting this. Now again, 8 by 14 into 0.811 plus 6 by 14 into 1. This is what the weighted thing will be. And we got 0.892 as entropy, and the information gain is very, very small. So we have calculated for all 4 now. For outlook, then gain is 0.247, temperature it is this, humidity it is this, wind is. This is highlighted, right? This is the maximum information gain it is giving. So first attribute that I should choose is the outlook. Make sense? Make sense? How to decide which should be my first attribute? So this particular entropy measure, in other way, mathematically gives you an idea of maximum information gain, right? We want to reduce the entropy, where the attribute which is reducing the entropy to a maximum, that is the attribute which is giving us a maximum information gain, and that is what we are choosing for a split. So the idea is to move towards pure partition, but mathematically, how do we check it? By calculating entropy values and then deciding. Does that make sense?
Sir, why can't we take the decision just based off entropic? Why we are calculating this information gain?
Information gain, it's just a measure. We can take a decision based on entropy values, right? But just for mathematical things, right? Which is the maximum one? So, okay, I've got entropy value of 0.693 right here. Let me check what are the other entropy. 0.911. Okay, let me write it here. This is 0.693. This is 0.911, right? For humidity, what we got is 0.789 and 0.892. Right? You can take a decision basis this. Now you have to choose minimum here. Right? That's a mathematical measure that they have designed, information gain. They subtract every value from the base entropy, which is 0.940. So 0.940 minus this is this value, 0.940 minus this is this value, 0.940 minus this is this value, and 0.940 minus this is this value. So out of this, they can take maximum. But if you want to go from this, right, you can take the minimum one and take a call. We can do that way also. Make sense, Anish?
Yes, sir. Got it.
Now, these steps we have to continue. As of now, we have only got outlook, right? This as the first attribute. Now, along this branch, again, we have to do the same things. How many records for Sunny, and then calculate the entropy, and which one gives us the least entropy that we have, then we can arrive at humidity. And on this side, then we can arrive at windy. So for Sunny, we know 5 records are there. For rainy, we know 5 records are there, right? So now basis those 5 records, you will calculate, you will check the humidity values, you will check the temperature values, you will check the windy values, and then which will give you the maximum information gain that you will pick up. Similarly, this side. No need to split further over cost because I have already got a pure partition there. That was ID3. Next is CART algorithm, which we will cover probably next time, right? It's the same data set, right? Taken. For a given play tennis data set, apply the decision tree algorithm and find the optimal decision tree. Also predict the class label for the following example. Sunny, hot, normal, windy is true. What should be the value, right? Now, CART is one more algorithm, right? ID3 is one algorithm, CART is another algorithm. Okay, what I would request all of you to do is for another 5-10 minutes, right? Some mathematics. We'll do CART next time. But at least for this data set, right, I can give you the data set here. And for one branch at least, this humidity branch, right? You after Outlook, take this Sunny branch and calculate those values for humidity, windy, as well as temperature, and then find out, okay, whether humidity is the right fit here or not, right? So I can give you the data set because data set you require. to do that. Yeah. First attribute is outlook. We know, right? Outlook, one side is sunny. Sunny is in pure again. So what next you will take a time? Will you do some calculations?
Sure, sir.
I know you have a class at 11:15, but our class was a little delayed today. So I would request you to do some calculation for 10 minutes, right? All of you, and share your answers. I just want a bio break, right? For a minute or so. I'll be back. So I'll be on mute, but you can share your answers. I'll be back in 5 to 10 minutes. Hello. Have we done something in this? Hello.
Yes, sir, doing a calculation.
Okay. Is everyone trying? Yamuna, Krishnan, Suchitra, Shweta. So in case you're not able to do here, take a screenshot of the data set and you should do it and share the calculations in the this Teams chat, right? You have to create a complete decision tree and share calculations. One calculation, if you can show me just to see if you are going in the right direction or not. Okay, another thing I wanted to ask is, have you received your EC2 results?
No, sir, no.
Not. Okay. Once you receive, before you apply revaluations, do let me know. We can have a 30 minutes extra session and I can discuss the solutions. Anish, one thing I would request,
sir.
one more thing. Let us create one informal kind of a WhatsApp group for this particular course, Applied Machine Learning. Will you facilitate that?
Sure, sir, I will do that.
Yeah. There are, I think, two batches which are merged together. So students from both the batches
sir.
should join. What I could see in the exam is wherever little bit of mathematics was involved, people are not answering, afraid to answer those questions. So practice as much as you can. This is a complete solution of decision trees, which I have given in the slides, right? Do a practice, and again, you will have a similar kind of a question paper in your final exam also. But at least answer certain questions which are very simple, right? I've asked a question, why do you divide a data into train and test? Even many of you have not answered it correctly. Some of you have answered it correctly, but many of you haven't. And I would encourage more participation in the class. While evaluating the answer books, what I could sense also is some students who are attending the sessions, they're able to write and they have an understanding of the concepts, but they're not participating in the regular sessions when I ask a question. I found 3-4 students like this, not more than that. But it will be good if you ask questions. Whatever comes to your mind, you can ask. What you need to take from the course, I will tell. Tomorrow you are going to have a lab session also. Professor Om Shri has posted an announcement. I request everybody to join, and immediately after that a lab sheet will be released. What we found in the lab sheet one was, I think many students have not submitted. See, losing EC1 components is I think you will be in big trouble. So my wholehearted request to everyone is submit the assignment, do it diligently yourself, and then submit. Soon there will be a lab assignment too coming. Individual assignment, 1 week time will be given. Within that week, you will have to submit. Largely based on classification task now, starting with maybe naive base, then logistic regression, SVM, all these three will be there. When you do assignment, right, you have to try something. Library call is fine. You'll get the code. You will apply on your data set. But do experiment. Which one is giving you better result? Try to understand which algorithm is giving these results and why. This will enhance your understanding of the course. Okay, all right. I think you have a class at 11:15. So Anish, any calculations you have done?
Yes, sir, I did the calculation for
Okay. Are you getting the
Sunny.
right answers that you are going to check the humidity after that?
Yes, sir, humidity first, then I think we will go for windy.
Hmm. So humidity is giving you the maximum information gain?
Yes, sir, yes, sir, as compared to windy, humidity is giving more information gain.
More information. You can check temperature also and then conclude that humidity is best. Okay, good job, Anish. I request everyone else also to participate. And one more thing, right? While I evaluated the answers, some of the answers were very brief, which is very good, and they were up to the mark. Some of the answers were still writing stories, essays, and all. That is not expected, right? You have to just talk about your understanding. Some word you know about it, you write here and there, it does not make any sense. Write to the point, but write valid reasons. We will discuss it, right? Once you receive, Anish, do let me know and create
Okay,
a
sir.
WhatsApp group today itself. So we are in close touch with each other. And if you have any questions and all, you can put it there. I can take it up in the class. So that's all from my side for today's session. Whatever is the lost time, maybe we'll see if we can conduct an extra session if it is required, right? So joins tomorrow's lab session wholeheartedly with your Jupyter notebooks ready and try to participate alongside the class as instructed if it's instructed by Professor Omshiri. Otherwise, you try it on your own on data sets and all and practice it. Any issues, anything related to lab, you can write to both of us. For conceptual things, you can write to me, definitely, right? That's all
Sir,
from my side. Yes,
sir, I have a question related to grading. Can I ask that?
yeah, go ahead.
So, like the relative grading, like in this course, there are two batches. So, the relative grading you do for each batch individually or the combined relative grading we get?